Carboxylic acid derivatives. Carboxylic acid derivatives can be prepared by replacement of the hydroxy group in the carboxylic acid, where carboxylic acid is carrying the C double bond O OH functional group. From this C double bond O OH, by replacing of the OH group with various of the compounds, we can get the carboxylic acid derivatives. In this we have acid chlorides, amides, esters, anhydrides. Acid chlorides, when the hydroxy group in the carboxylic acid is replaced with the halogens like chlorine, bromine or the iodine, we get the acid halides. And by replacement of the OH group from the carboxylic acid and by introduction of the NH2 group, it becomes amide or CONH2, and by replacement of the alkoxy group with OR, OH, it is giving the anhydride. So, like that we get the different compounds by replacement of the hydroxy group from the carboxylic acids. Now, we will see the preparation of the acid halides. In the acid halides, we have the C double bond O and X functional group. Here the X, in place of X you can keep the chlorine, bromine or the iodine. Based on that we have the variety of the acid chlorides and acid halides here. And the preparation of this acid halides by using various reagents. First we will prepare this acid halides by using the phosphorus pentoxide. Here is a carboxylic acid is treated with the PX5. This is a phosphorus pentahalide. When it is treated with, it is giving the RCOX is a major product here, and POX3 is a byproduct, and hydrogen chloride acid is evaluated in this reaction. Here is a acetic acid CH3COOH. When it is treated with the thionyl chloride, so it gives the acetyl chloride CH3COCl. This is the acetyl chloride which is obtained of the reaction of this particular acetic acid with thionyl chloride, and the HCl is a byproduct in this particular reaction. And you can prepare this particular acid chloride by treating with phosphorus pentachloride CH3COOH. Acetic acid, when it is treated with the PCl5 phosphorus pentachloride, it is giving the acetyl chloride CH3COCl and phosphoryl chloride POCl3, and HCl is a byproducts in this reaction. And the reactivity of this derivatives. Generally this particular acid chlorides, where it is carrying the carbonyl group CO group here. So, this carbonyl group, due to presence of this carbonyl group, these acid halides are undergoing the nucleophilic substitution reaction. Here is a Y minus, it is a nucleophile when it is attacking at this carbonyl electrophilic center, where this pi bond is polarizing on this oxygen, because here the Y minus, it is a base where it is forming the bond with this carbon. So, already the carbon carrying the 4 bonds here, when the Y is attaching, it becomes 5 bonds. Generally for carbon the 5 bonds are not accepted, because the valency of carbon is a 4 only. So, to facilitate for this attachment of this base, so where this particular oxygen, it is taking this pi bond electrons, and it is becoming the oxide ion, and this oxide ion upon repolarization in between the oxygen and carbon, where it expels the halide ion X minus. So, finally, it is giving the R C double bond O Y. Y is the incoming nucleophile here, and X minus is evaluated in this particular reaction. So, this is the reactivity, where due to presence of this carbonyl group, it is able to participate in the nucleophilic substitution reactions. And we can have the variety of reactions by reaction of with various reagents here. Here is the RCOX, here is the acid halides. When it is treated with the ammonia, it is giving the amide main product here, and X is a halogen, any halogen. You can, in place of X, you can keep the chlorine, bromine or the iodine. And here is a acetyl chloride CH3COCl. When it is treated with the ammonia, it is giving the acetamide, the primary amide product, and HCl gas is evaluated in this reaction. And here is this particular acid halide. When it is treated with the alkyl amine, right. So, we are getting the secondary amine here. Here the primary amide, secondary amide and tertiary amide, it is classified based on the number of alkyl substituents present to this nitrogen of your amide group here. In this particular acetamide, we have only one alkyl group. Here is a CH3CO. This is only one alkyl group is attached to this nitrogen. So, it is primary amide. And here in this particular CONH2, CONH, where here is a one alkyl group, and this side also one more alkyl group is attached here. So, it becomes secondary amide. If this hydrogen also replaced with one more alkyl group, then it becomes tertiary amide. So, you can prepare primary, secondary and tertiary amides by reacting with a variety of amine derivatives here. Next, formation of esters. Here is a alkyl halides. When it is treated with the alcohol, so it is giving the esters. Here is a RCOX. When it is treated with alcohol ROH, it is giving the ester compound. Acetyl chloride, when it is reacted with methyl alcohol, methanol, it is giving the methyl acetate is a main product here. And when this particular alkyl acetyl chloride, when it is treated with the aromatic alcohols like phenol, so it is giving your aromatic amides here, aromatic esters. Here is a acetyl chloride. When it is treated with phenol C6H5OH, so it is giving your phenyl acetate is a major product in this reaction. Next, R and I ester synthesis. Generally, the R and I ester synthesis is useful method to prepare the higher number of the carboxylic acid, and this R and I ester synthesis can be proceed by formation of the acid chlorides. Here is a carboxylic acid. When it is treated with the thionyl chloride, first it gives a acid chloride here, where it evaluates the sulfur dioxide gas and HCl gas here. Then this acid chloride is treated with the diazomethane reagent, and it is forming the diazomethyl ketone intermediate compound. And this diazomethyl ketone intermediate compound, further by rearrangement of this alkyl group, it is giving your higher carboxylic acid. In this particular starting material, you have one alkyl group is there, and immediately it is attached to the carboxylic acid group here. And in the product, if you observe, one more carbon is introduced in this particular RCOOH. Here is a RCOOH. In the product, it is RCH2COOH. So, one carbon increased in the product. So, to increase the carbons in the carboxylic acid, the best method is R and I ester synthesis. So, likewise, you can prepare aromatic carboxylic acids also, where you can take the benzyl chloride. it is treated with the diazomethane and we are getting this particular benzamide is a derivative in this particular compound here. Next, Friedel-Crofts acylation reaction. Friedel-Crofts acylation reaction is one of the best method to introduce the acyl group on the aromatic ring. Generally, the aliphatic acyl groups cannot be introduced in this particular example. Only the aromatic acetyl derivatives can be prepared. Aliphatic acetyl derivatives cannot be prepared by this Friedel-Crofts acylation reaction. So, if you see the reaction, here is a benzene when it is treated with the alkyl acid chloride in the presence of anhydrous aluminum chloride, it is giving your carbonyl compound, that is a ketone. Here is a benzene when it is treated with CH3COCl in the presence of anhydrous aluminum chloride, we are getting this particular benzene COCH3. And the Rosenmund reduction. By this Rosenmund reduction, we can get the aldehyde derivatives here. Here is a acid chloride when it is treated with this reaction with hydrogen in the palladium barium carbonate, barium sulphate, we are getting this aldehyde compound here. Here is a CH3COCl when it is undergoing the reduction reaction. Generally, this reaction is the reduction because we are adding the hydrogen to this particular compound. So, addition of hydrogen is called the reduction and addition of oxygen is called the oxidation. So, in this reaction, the Rosenmund reduction involves the addition of hydrogen to this particular acid chlorides, where this acid chloride when it is addition of the two hydrogens in the presence of palladium barium sulphate, we are getting this particular acetaldehyde is a major product in this reaction. So, same way you can prepare the aromatic aldehydes also, where this benzene carbonyl chloride when it is treated with the hydrogen in the presence of palladium barium sulphate, we are getting this benzaldehyde product here. And acetamide preparation, when this particular carboxylic acid it is treated with this ammonia, so we will get this particular ammonium salt of the intermediate compound, and upon heating where the dehydration of this particular ammonium sulphate leads to formation of acetamide is a product here. Next, here is a acetic acid when it is reacted with ammonia, we are getting the ammonium acetate is a intermediate compound, and this ammonium acetate upon heating at a particular temperature where it leads to removal of water, dehydration, giving your acetamide derivative here. And coming to this properties of the amides here, generally the amides is having the polar NH2 groups and CO group here. So, due to presence of polar NH2 group, it able to form the intermolecular hydrogen bonding. So, due to formation in the intermolecular hydrogen bonding, its boiling point and the melting point values will be more. If you see the means it is the boiling point and the melting point values are more than your corresponding carboxylic acid here. Here is a carboxylic acid and acetyl halide and the amide. So, the comparison of the melting point and the boiling point is given, where acetic acid its boiling point is 118 degrees Celsius and acetyl chloride where it is having the boiling point is 51 degrees Celsius and amide is having 221 degrees Celsius. So, you can have the idea about the boiling point and the melting point of your amides here. So, the more increase of the boiling point in this amides is due to presence of intermolecular hydrogen bonding between the amide compounds here, right. You see here the acetic acid it is only 118 and here amide is having 221 degrees Celsius boiling point values. This is only due to intermolecular hydrogen bonding between the amide compounds here. and the reactions of this acid chlorides and the amides here. So, where this particular amides are undergoing the hydrolysis reaction in the presence of acid medium or the basic medium. So, it is giving the carboxylic acid is the main product and it evaluates the ammonia gas. And the dehydration reaction, where this particular amides is reacted with phosphorus pentachloride and it gives the nitriles or the cyanide is a main product in this reaction and the water is a byproduct in this particular reaction. Next, Hofmann bromamide degradation reaction. This is one of the famous reaction to prepare the primary amines in the reaction here. So, the example is taken where this particular primary amine is reacted with the bromine molecule in the presence of KOH and adding some water, it is giving the RNH2 primary amine and the KBr and K2CO3, potassium carbonate, potassium bromide, these are the byproducts in this reaction. And the mechanism of this Hofmann bromamide degradation reaction, where in this particular amide, first the one of the hydrogen is captured by the base. So, for this base purpose we are using the KOH here. So, KOH acting as a base. So, this OH minus, it is abstracting the proton from this amide nitrogen here and it becomes the, this is the N minus here, and this N minus further where the negative charge on this particular nitrogen, it is attacking on this bromine molecule and it is capturing the bromine and it becomes N bromoamide here. N bromoamide intermediate further where it is reacted with your one more mole of the base and the one of the hydrogen also captured by this base here and it becomes a intermediate compound here, nitrine intermediate compound. And this nitrine intermediate compound further where by rearrangement of the alkyl group here, where the negative charge on this nitrogen, it is shifted towards this carbonyl group here, then it leads to rearrangement of this alkyl group from carbon to this nitrogen is taking place and we are getting this particular intermediate compound. And this particular intermediate compound further undergoing the hydrolysis and it is giving your amine here. Next, acid anhydrates. In the acid anhydrates, we have the, it is symmetrical derivative compound here, where the preparation is done by using the 2 moles of carboxylic acid. You can use the 2 moles of carboxylic acid in the presence of phosphorus pentoxide and we are getting the anhydrate is the main compound in this reaction and the water will be evaluated in this particular reaction here. For example, here where the alkyl sodium salt of the carboxylic acid, when it is reacted with the acid chloride, it is giving your anhydrate compound. And some cyclic derivatives also, the cyclic anhydrate derivatives also can be prepared by heating, simple heating of the dicarboxylic acids here. Here is a dicarboxylic acid, when it is heated at particular temperature, where by evaluation of the water here, this is the OH from this terminal and the hydrogen from this terminal, where by removal of the water, where you can have this particular anhydrate, cyclic anhydrate derivatives. And here is also with the succinic acid, upon the dehydration of this succinic acid, we are getting this particular succinic anhydrate. And the phthalic acid also undergoing the dehydration reaction and phthalimide is a product in this particular reaction. So, same way you can prepare the variety of cyclic anhydrates and acyclic anhydrates by following the reactions here. And the hydrolysis of anhydrates. Generally, the anhydrates hydrolysis leads to formation of carboxylic acid. Here is the anhydrate compound where it is carrying the RCOOCOR here. Upon reacting with the water molecule, where the cleavage of this bond, cleavage of this CO bond is takes place and it leads to formation of 2 moles of carboxylic acid here. Here is a acetic anhydrate. This is the example where we are taken the acetic anhydrate when it is undergoing the hydrolysis reaction where by cleavage of this bond from the water molecule. So, in the H2O the hydrogen is attached to this oxygen and it becomes acetic acid here, and the OH is attached to this CO group here, then it becomes acid. So, we are getting 2 moles of carboxylic acid. In this way you can prepare the multiple carboxylic acid by hydrolysis of your anhydride compounds. Next, the reaction with alcohols. Here the reaction with alcohols also leads to formation of the esters and the carboxylic acids here. And the Friedel-Crop acylation reaction. Here the Friedel-Crop acylation reaction leads to formation of the ketone derivatives here. Here is a benzene, when it is treated with the acetic anhydride in the presence of anhydrous aluminum chloride, we are getting this particular acetobenzene here. This is the acetobenzene and the acetic acid is your byproduct in this reaction. Next derivative is the esters. Here the esters is simply prepared by reaction of the acids with alcohol. Here is a carboxylic acid, when it is treated with the alcohol it is giving your ester compound, and the water is a byproduct in this particular reaction. So, you can repeat this reaction by using this acetic acid and the ethyl alcohol. Here is the acetic acid and the ethyl alcohol react together and it is giving your ethyl acetate ester derivative. And the aromatic esters also you can prepare by reaction of the acetic acid with particular alcohol here. Here is a benzoic acid, when we are treated with the ethyl alcohol it is giving ethyl benzoate is the main compound in this particular ester formation. And the reactions of these esters, majorly the esters involves in the hydrolysis reaction and it gives the carboxylic acid and alcohols here. Here is the RCOOR, and when it is undergoing the hydrolysis in the presence of acid medium or the basic medium, it gives a carboxylic acid and the alcohol. The two derivatives are prepared from this particular hydrolysis of your esters. And here acyl oxy cleavage and the alkyl oxy cleavage. So, during this particular hydrolysis, so which oxygen is cleavage, which bond is going to cleave. So, to confirm this we can do the reaction by isotopically labeled oxygen here. So, here is a RCO and OR, when it is undergoing the hydrolysis. So, we are getting this RCOOH and R and OH. So, you here in this particular ester we have the isotopically labeled oxygen is there, and this isotopically labeled oxygen is coming in this alcohol compound here. So, we can have the idea that where the acyl group is acyl oxy cleavage is taking place, and the alkyl oxy cleavage means RCO cleavage is taking place or not. So, to confirm this we can repeat this reaction by replacing the oxygen with its higher isotope like O18. Generally the oxygen is existence in the O16 and O17, O18 is the isotopes of the oxygen here. So, to confirm that we can repeat this reaction by keeping the higher isotopes of the oxygen, and if you get the same element in the product. So, we get the idea that this particular cleavage is taking place. So, to confirm that which bond is going to cleave, so we are repeating the reaction by labeling with the isotopes here. Next, transesterification. So, transesterification means where the one of the alcohol group in the carboxylic ester is replaced with the outcoming alcohol here. And here you see this RCOOR prime, it is treated with the R double prime OH. So, where this OR prime it is replaced with the R double prime O here. So, where the exchange of alcohol is taking place. So, the exchange of alcohol is called the transesterification, and the mechanism of this transesterification is given in this particular mechanism. So, you see this is the ester compound when it is undergoing the protonation with acid. So, we are getting the protonated ester compound, and further you see where this proton H plus is attached on this oxygen of your carbonyl group of ester, and due to the carrying the positive charge on the oxygen, where this CO bond pi bond is polarizing on this oxygen and it is neutralizing the oxygen here. So, this carbon gains a positive charge, and then your alcohol is attaching it to your electrophilic this carbon center here, and when this carbocation is attached with your alcohol, you have this intermediate compound, and the replacement of this particular hydrogen bond towards this oxygen, it is neutralizing this positive charge here. And further, where it is going to remove of the alcohol from this particular intermediate compound, and we are getting this intermediates here, and by finally by removal of water from this particular intermediate compound, it gives your ester compound with exchanged alcohol here. So, in the reactant you have the R prime, in the product we are getting the R double prime here. So, this is the mechanism of the trans esterification, where the exchange of the alkyl group is taking place here. So, this is the derivatives of the carboxylic acid, and in the carboxylic acid derivative we have various types, like means variety of the derivatives, the acid chlorides, acid anhydrides, acid amides, esters. So, these are the and anhydrates. So, these are the derivatives of the carboxylic acid, and these variety of derivatives can be obtained by replacement of the hydroxy group from the carboxylic acid by variety of reagents. We are getting different different derivatives. For example, if the OH group in the carboxylic acid is replaced with the halogen, it gives a acid halides, and when this particular OH group in the carboxylic acid is replaced with the OCOR, it is giving your acid anhydrate, and when the OH group in the carboxylic acid is replaced with the NH2 group, it becomes the amide derivative here, and when this particular OH group in the carboxylic acid is replaced with the alkoxy group, then it becomes ester compound here. And the preparation of these variety of derivatives by taking place by various means, if you take this acid halides, easily prepared by reacting with phosphorus pentahalide or thionyl chloride, or you can take the phosphoryl chloride also. So, by these reactions you can prepare the acid halides, and this acid halide generally these are not polar compounds, because there is no more electronegative atoms in this one, and due to presence of this carbonyl group, these compounds undergoing the nucleophilic substitution reactions. So, where the Y minus, where this nucleophile is attacking it to electrophilic CO group here, and it is giving your means where the replaced of the X with Y minus here, and the esters, where this particular esters is reacted with alcohol, and we are getting this particular ester derivative here. And you see one example here, where you can take acetyl chloride when it is treated with the ethyl alcohol or the methyl alcohol. So, we are getting the corresponding ester derivatives here, and in the same way you can prepare the higher number of the carboxylic acid by following the R and I ester synthesis, and R and I ester synthesis is one of the major method to prepare the with increased number of carbons in the carboxylic acid, and which is proceed by the formation of the acid chloride here, where this acid chloride when it is reacted with diazomethane, this is your diazomethane, and this diazomethane is attached to this particular carbonyl acid chloride, and it is giving the diazomethyl ketone, and this diazomethyl ketone upon hydrolysis and followed by the rearrangement of the alkyl group from this acyl group, where it is giving your increased number of the carboxylic acid here. and the Friedel-Crafts acylation reaction, where you can introduce the acyl group on this particular aromatic compounds, and you can prepare the aromatic ketones here. Aromatic ketones, only aromatic ketones can be prepared by the Friedel-Crafts acylation reactions, and the aliphatic ketones cannot be prepared by this Friedel-Crafts acylation reactions here. And the Rosenmund reduction, where the Rosenmund reduction is one of the method to prepare the aldehydes here, aromatic and aliphatic aldehydes. Both aldehydes you can prepare by this method. Here is a acid chloride. When it undergoing the hydrolysis, when it is undergoing the hydrogenation reaction in the presence of palladium barium sulfate, it is giving the aldehyde here. One example is you can take acetyl chloride. Upon reaction of this particular acetyl chloride with palladium barium sulfate, it is giving the acetaldehyde is a main product in this particular reaction. And benzoaldehyde also you can prepare by taking the here the benzoyl chloride here. Benzoyl chloride undergoing the reduction in the presence of palladium barium sulfate, it is giving the benzoaldehyde compound. And acetamide, one more derivative is the acetamide. So, you can prepare the acetamide by reacting of the ammonia with carboxylic acid, and we can prepare the acid amide. So, in this way you can prepare the variety of the derivatives by reacting with variety of the reagents to this carboxylic acid.